Function generator safety precautions. First, proper environment. Use the function generator in a clean, dry, and well-ventilated environment. Keep it away from liquids to prevent electrical shock. Second, inspect the equipment. Before its use, inspect the function generator and its cables for any visible damage. Do not use the equipment if you find any issues. Third, voltage and current limits. Do not exceed the generator's maximum output ratings to prevent damage to both the generator and the connected equipment. And the last, power source. Ensure that the function generator is connected to the correct power source and voltage to prevent damage. Function generator setup. First, before you begin, make sure to follow safety guidelines and ensure that the function generator and your test setup are properly grounded. Next, plug in the function generator and turn it on by pressing the power switch. Function generators offer various waveforms options, including sine wave, square wave, and triangle wave. Select the desired waveform using the waveform selection control or menu. Make sure that the function generator is connected directly to the oscilloscope by using the output leads. Adjust the frequency and amplitude to the desired value. This can be done by using the frequency knob and amplitude knob. Operating the function generator. Connect the function generator's output to the device or circuit you want to test or apply a signal to. Use appropriate cables and connectors. Use an oscilloscope or a suitable measurement instrument to verify that the generated signal matches the desired waveform, frequency, amplitude, and other parameters. Adjust the function generator settings as necessary.
Before we start using the oscilloscope, here's some safety precautions. First, use proper accessories. Ensure that you use probe, cable, and accessories recommended by the oscilloscope manufacturer. Using incompatible or damaged accessories may lead to inaccurate measurement or equipment damage. Second, inspect the equipment. Before each use, inspect the oscilloscope's probe and cables for any visible damage. Do not use the equipment if you find any issues. Third, calibration checks. Regularly check and calibrate the oscilloscope to ensure accurate measurements. If you notice any discrepancies or drift in readings, address the issue promptly. Fourth, proper environment. Use the oscilloscope in a clean, dry, and well-ventilated environment. Keep it away from liquids to prevent electrical shock. Here is how you set up the oscilloscope. First, plug in the lead to the channel 1 terminal and change the mode to the channel 1 mode. Ensure that the trigger hold-off button is set to auto, and make sure that the source channel is set to the input channel that you're connected to, which is channel 1. The VAR dial should be set to CAL by turning the dial clockwise until it clicks. Here's how we measure the voltage. The vertical position dial is used to change the position of the signal's display relative to the grid. The volts per division dial changes the scale of the displayed signal voltages and is used to ensure that the entire range of the signal is displayed on the screen. Here is how we calculate the peak-to-peak voltages. First, we count the numbers of divisions between the maximum and the minimum signal. Then, it will get multiplied by the volts per division setting and will get the value of the peak-to-peak voltages. Measuring period and frequency. The horizontal position dial is used to change the position of the signal displayed relative to the grid. The time per division dial changes the time scale of the displayed signal. It is used to ensure that an entire cycle of the signal is displayed on the screen. Here is how we calculate the period of signal. First, we count the numbers of horizontal divisions between successive crests of signal. Then, it will get multiplied by the time per division setting and will get the value of period signal.